Hello everyone, my name is Zijian from BUPT, Beijing University of Posts and Telecommunications, and it's my great honor to present our work, D2Park. It's a joint work of BUPT and Rutgers University. Here is the outline of my presentation, and I will give a brief introduction of the background first. With the continual growth of population and vehicles in many cities, people are faced with increasingly serious parking pain. Recent surveys show that massive amount of time, fuel, emissions are wasted in searching for parking spots. In recent years, many innovative parking apps have emerged to help drivers to find a convenient off-street parking spot with useful information, such as parking availability, price, and distance. By contrast, on-street parking has some unique characteristics, such as less spots for temporary use, more immediate influences on the traffic, which make it necessary to design mobile apps for on-street parking guidance services. Fortunately, the recent advances of Shenzhen technologies have enabled large-scale, low-cost, and continuous monitoring of on-street parking occupancies. And various parking services are provided. Parking occupancy prediction can increase the probability of finding free parking spots, but in turn, it changes the driver's behavior from searching to competing for parking, resulting in the phenomenon of multi-cars chasing the same spot. The other way to provide parking service is to provide parking reservation services. However, it's impractical to treat all spots as reservable resources. So, what's the realistic on-street parking scenario and how to provide a proper parking guidance service? To solve the above problem, we then conduct a qualitative investigation based on the online survey data. There are 11 questions and 203 participants on the survey, and the results indicate the necessity of providing both recommendation services and reservation services for diversified requirements. To satisfy diversified requirements, we divide the users into different types, involving reserved users who request a guaranteed spot at the cost of a reservation fee, normal users who request a non-guaranteed spot with the best effort recommendation services, and external users who does not send any request and directly drives to a street for parking near her or his destination. And it's challenging to simultaneously consider the three classes of users for achieving high efficient dynamic resource allocation due to the following reasons. As mentioned above, the diversified requirements should be comprehensively considered and should be well balanced. The allocation mechanism should be adjusted for various users, such as the comparison-based mechanism is suitable for reserved users, and for normal users, the competition-based mechanism is more applicable. Different allocation mechanisms, together with uncertain external demands, have complex mutual influences on the resource availability. And finally, to improve the resource allocation performance, it is needed to consider not only current parking requests and occupancy status, but also uncertain demands and occupancy dynamics at fine-grained temporal levels in the future. Thus, we design a parking guidance system. The sensing component monitors the real-time occupancy status and stores it in the database. The computing component first predicts the future occupancy status and then outputs the guidance results. For user end, the service component is encapsulated as a parking app. We first utilize the prediction module to predict the parking inflow and PUR, which combines the graph convolutional neural network and the long short-term memory neural network to predict a sequence of parking demands and occupancy status on each street block based on the current parking events and other external factors. With the prediction results, we design the diversified parking guidance module, which consists of three parts: DGMNC, competition-based mechanism for normal users, DGMRC, comparison-based mechanism for reserved users, and joint parking guidance, a three-step joint guidance algorithm that coordinates the mutual influences of DGMNC and DGMRC. Then, we design 5 evaluation metrics and 2 baselines. We also evaluate our system under sufficient comparison experiments. The average parking delay time has been reduced by at least 33% through the verification of more than 62 million real-world parking data in Shenzhen, China. Finally, this is the framework of our D2Park. Thank you for your watching.